the first question I got is about something like this. Negative 7b is less than or equal to 35. So you're asked to solve and presumably graph an inequality. Now I like this one because it's asking you to deal with something that has a negative coefficient here. To solve this one, what do you think you do? Divide by negative 7. All right, so we'll divide by negative 7. The reason I like this one is because at this step you've got to remember something important. What is it? Yeah, the direction of the inequality changes when you divide or multiply both sides by a negative. That changes the direction of the inequality, so it's going to be b is greater than or equal to negative 5. As far as the graph is concerned, let's draw ourselves a little graph here. The only thing I like putting on my graphs is exactly what I need, which is a negative 5. What kind of a dot am I going to put on that negative 5? Solid dot. And which way does the arrow run? To the right. Now, we're fortunate because the variable is on the left-hand side of this inequality. And when that's true, then the inequality points in the direction you're going to draw your graph. This inequality, though, would be the same as negative 5 is less than or equal to b. But it would still have the same graph. It's only when the variable is on the left-hand side that the inequality points in the direction that you're going to draw the graph. So be careful with that. It is a nice little hack on some of your problems, but it's not going to work for everything. Next one's kind of a little bit of a general question. This is, what's the right way to explain direct variation? I guess there's a couple different answers that I would give on that one. First of all, in terms of the graph, direct variation, what do you know about the graph of something that varies directly?
Goes to the origin.
Yes, exactly. It goes through the origin. So one way or another, it's going to pass through the origin. It doesn't matter exactly what the slope is, but it's going to pass through the origin. So that's one thing. It passes through 0, 0. The form of that equation then has to be y equals m times x. It's just some slope times x. Now how come I don't have a plus b here? Well, b is 0 because you're going through the origin. Another kind of test for something that has direct variation, if you double the input, you should double the output. So, for instance, some of the problems that we had dealing with direct variation were stuff like this. So we had y equals, say, 9x, where x is the number of pizzas that you ordered. So if you order x equal 10 pizzas, then y cost you $90. But if you order x equal 20 pizzas, how much is y going to cost you now? $180. So when you double the input, you double the output. So that's another kind of characteristic of direct variation. So far, so good on these. I'll put the notes from this stuff up online, so I'll scan this in if you're like worried, like, God, is he writing so fast? I don't know. I was just pumped up from this morning or something like that. I'm not sure. But in any case, looking good there. Let's keep going. I'm going to try and do one from everybody's handout, and what I've done is I've looked through to try and figure out, well, what's the most relevant? What part do I think I should do on each person's set of 3 questions? Let's keep going. You lost? Oh, you're lost eraser?
Yeah. I was looking
There you go.
for that for a while.
How do I know what and where to put the, I guess the values in y2 minus y1 over x2 minus x1? So let's do that. Let's figure that one out. And for this, let me choose a couple particular points. 0 and 32. and then 100 and 212. Now, just out of curiosity, does anyone think about temperature and see the significance of these points?
Freezing, boiling.
Yeah. So this is the freezing point of water in Celsius, and then in Fahrenheit, Celsius and Fahrenheit, and then the boiling point of water in Celsius and Fahrenheit. What if I wanted to figure out the slope of a line between these 2 points? I could do that. So what you have to do is you have to decide one of these is going to be your x1, y1, and the other one's going to be your x2 and y2. So our slope formula is the difference in the y coordinates divided by the difference in the x coordinates. And the thing that I would say about this is you've got to be consistent in which order you subtract those things. So in the numerator, it's going to be 212 minus 32. In the denominator, it's going to be 100 minus 0. So we get 180 over 100. Now, just a little hack here that you can do to kind of simplify this a little bit. Since both of these end in a 0, I can divide by 10 by crossing out a 0 like that. Okay, I'm left with 18 over 10. What number goes into both 18 and 10? 2. 2 goes in here 9 times and in here 5 times. So that's the slope of a line between those two. What if you're worried that, what if I mixed those up? What if I did, this was my x1, y1, and this is my x2, y2? Okay, let's try it that way. x2, y2, x1, y1. Let's calculate the slope this time. It's going to be 32 minus 212 over 0 minus 100. What am I going to get in the numerator? Yeah, negative 180 over negative 100. What happens to the negatives? Yeah, they cancel. You're just left with 180 over 100, and we already know that that's 9/5. Let's go a little bit further here. And that little bit further would be, let's actually figure out the equation of a line with these two things. I think I saw that as a couple of your problems. So there's a couple ways I could do this. Kind of depends on you. But one way that I could do this is with the slope and intercept form. So that if I have at least a point and a slope, then I can do this. The point slope, I said slope and intercept, I'm sorry. Point slope form of a line is this. Assumes you have an M and assumes you have x1 and y1. If I know both of those, I can plug this into an equation. Okay, so let's see what I've got for these two things. Now, I've got 2 points and a slope, so I can choose whichever one I want. Which one of those looks easier? The first one or the second one? Which one would you want to plug in? Yeah, I'm liking that first one all day, right? You got a 0 there. That's going to make things easier to plug in. So it's going to be y minus 32 equals 9/5 times x minus 0. If I distribute the 9/5, I get y minus 32 equals 9/5 x. What's 9/5 times 0? Do I really need to write the 0 there? No. Last but not least, let's move that 32 to the other side. When that happens, what happens to that 32? It becomes a positive. You might recognize this in a different form. This is how to get from degrees Fahrenheit, or from degrees Celsius to degrees Fahrenheit. Multiply by 9/5 and then add 32. Cool. The point here is that if you're given 2 points, you can find the equation of a line. Let me show you how you do that in another way. What if you're just going to say, all right, let's use the slope-intercept form. The slope-intercept form of a line looks like this. Y equals mx plus b. Beautiful. Looking good. Let's see. In this case, we know what m is, right? M is 9/5. 9/5 x plus b equals y. You can plug in a value for x and y and then solve for the only unknown, which would be b. Since I know a point on this line, let's use 0 and 32. Let's plug that in, and that'll allow us to solve for b. So that's going to be 32, which is your y value, equals 9/5 times x plus b. Nine-fifths of 0 is 0. So you get 32 equals b. And then just be a good sport about this, if you would please go back and plug in that value of b into your original equation. And then you get your value for, well, you get the whole equation. Y equals 9/5 x plus 32. So you get the same thing. They match. Any preference? Do you like the first way better than the second way, or doesn't it matter? I mean, it's up to you. You'll certainly be, certainly it's a reasonable problem to expect to find the equation of a line if I give you 2 points. I mean, this is something that does get used a lot.
I feel like the second one seems nicer because it's set up a little bit easier.
The second one is pretty nice.
I was confused that they were interchangeable at first. Like, you could use either or
Mhm.
to find the equation. I thought it was just the first one.
Okay.
Then I realized that.
You know, for a long time in my teaching here at OCC, I've pretty much used this one, but I've gotten a little bit more sympathetic to the fact that it works easy both ways. So it's up to you. I'm not going to, grade you down if you use one versus the other one. It's just whatever works for you. Okay, let's keep going. So I got a few questions about r squared. And let's go back and understand, or excuse me, not r squared, r. R squared is for my stat class. R is our linear correlation coefficient. So just to remind you, let's take a look at the extremes for your linear correlation coefficient. And let me see if I can't make that a little bit bigger. There we go. So what are the extremes? What's the biggest that r could be? What's the smallest that r could be? 1 and -1. Now, if you got a 1, then everything is perfectly on a straight line. That straight line has to have a positive slope, though. If you have a r of -1, then you got a perfect negative linear correlation, but everything's perfectly on a straight line. By the way, on the test, on your quiz, what was the correct answer for us on the quiz? We can maybe look at that for a second.
78.
Yeah, it's 0.78, all right? Let's see, I should have another copy of it someplace. Yeah, here we do. So on the quiz, what you can eliminate, first of all, was these, right? It didn't have a negative coefficient at all. And then another way we can eliminate was this one pretty quickly. How come I can eliminate the 0.99?
Was there like a straight line there?
Yeah, it'd be pretty close to an exact straight line. It wouldn't be exactly perfect, but it'd be really, really close.
Yeah.
There's one more I can eliminate. That'd be the 0.03. Why can I eliminate the 0.03? Yeah. If you had a correlation coefficient of 0 or near 0, then you're going to get a random looking picture like you have in graph C here. It's just all over the place. So there's no rhyme or reason to it. Now, example F here does show another example of R of 0, but that's because even though this has a relationship, it's not a linear relationship. It's not a line. A line doesn't summarize the relationship between X and Y here. So that's why you get a 0 there.
Just to be clear, R is like the linear relationship.
R is
right?
the strength of the linear relationship.
okay.
Yeah, so it's how close to a straight line you are. So like this one was negative 0.94, that these points are pretty close to a line and they're not perfect. So that's why you're a little bit away from -1. You had another follow-up there.
So like for when it's closer to like for the test 0.78, it would be like a linear relationship.
Yeah, it's
right?
it's closer to a linear
Okay.
relationship. And that's what we saw on this one here, is that, yeah, that's the only one that really makes sense. So that was our final answer on this one, because these are pretty close to a line. Are they perfect? No. If they were perfect or near perfect, they'd be much closer to a line, and that would reflect a 0.999. It's not random. It has to be this one. So, all right. Good question. Good question. Let me keep going. So, asked to solve this inequality. I guess what I want to emphasize about something like this is that when you're solving these types of equations and inequalities, you want to look at what your variable is. In our case, the variable here is an A. And ask yourself, what's being done to A? Are you multiplying A by something? You're adding A to something?
Dividing.
We're dividing. What's the opposite of division?
Multiplication.
Multiplication. What should I multiply by?
A.
4. All right, multiply both sides by 4. Now on the left-hand side, this 4 and this 4 cancel each other out. You're left with A is less than or equal to 80. Now were you paying attention earlier when we graphed some stuff? Let me put the 80 here. What kind of dot?
Close.
Closed. Someone else now. Which way does the arrow run, left or right? Left. How do we know? Yeah, because it's a less than, it's pointing that way. If your variable's on the left and it's pointing that way, it's going to go to the left. Awesome. Awesome. Okay. How many pizzas can you order if your budget is $200 but the delivery charge is $16 and each pizza costs $22? We're living high and high. This better be some high-end pizza here, right? $22 a pie? All right. I mean, we're going down to maybe Como's in Ferndale or something like that. They actually there'd probably be an undercharge for Como's. I mean, their pizzas are more like $25, $30. Some of them crazy. They're good. They're really good. But that's like, okay, I want to treat myself to something nice, kind of good. Yeah. Yeah. All right. How many pizzas can you order if your budget is $200? So that $200, do I want the cost of my pizzas to be more than $200 or less than $200? So the cost of the pizza is $16 per pie plus $22 extortion. I mean delivery. So which way should I run the inequality? Should it be greater than or equal to or less than or equal to? Talk amongst your friends for a second. Try and decide which direction that inequality goes because it makes a difference.
Oh no, you're right. I did wrote mine at 5. Vertical, right? Yes. The alligator teeth. So then that's where. Okay.
I'm glad to hear somebody using that. It actually works, huh?
So like
Alligator is a bigger number?
Yeah,
Yeah, it does. I've been using that one. I used to blush when I say it, but now I'm over it. I'm like, okay, it works. All right, it works.
But I was overthinking it too when I first did it.
All right,
That's why I just
Alicia, what are you thinking? Which one of these should I do? Should I do a greater than or equal to or a less than or equal to? Greater than or equal to? Do we agree here? Yes. Because that makes the cost of our meals smaller than our $200. So that's the right way we want to do this. Let's subtract 22 from both sides. I get 178 is greater than or equal to 16p. If you divide both sides by 16, 178 divided by 16 is greater than or equal to 16 over 16p over 16. On the right hand side, you're just going to get your number of pizzas. On the left hand side, give me a second here. I think you'll get 11.125. Someone check me on that. Woo! Sensei Jeff knows all, sees all. All right. Lottery predictions later. All right. Now, is Como's going to allow you to order 11.2 or 125 pies?
No.
No. So what should you order? 11. So yeah, choose 11. Taya, you got a question?
Why is it 16p and not 22p?
Oh, I mixed these up, didn't I?
Yeah, you did.
Okay. Tell you what. I think the author of the problem really meant for it to be the other way around. So we're ad-libbing here a little bit, but no. Hopefully you get the right idea. Yeah, I mixed these up. Each pizza costs $22. Whoo, man.
That's it.
Yeah. But do you get the idea? Do we need to resolve this one? We're good there? Thank you. Thank you. All right. Let's keep going. What's the easiest form of equation to graph? If you're asked to graph something, I've always thought it was easiest to have it in, slope-intercept form. And the reason for that, ladies, is quite simple. Let's take a look at our last one, right? The cost of ordering pizzas. And I'm going to stick with the way I wrote it, or the way I miswrote it, I should say. 16x plus 22. If I wanted to graph this, first of all, I know where I start on the x-axis, right? Where's my point? It's not on the x-axis, but on the y-axis. Where do I start? Yeah, I start at 22, right? So when x is 0, y is 22. And here's an easy thing. If I wanted to figure out where this point is, when x equals 1, I'm just really going to add that right there. Now let's take a look at it in two different ways. So if I put in a 1 here, I get 16 plus 22 is 38. And that's fine. But usually when I do this for myself, I don't think of it as plugging in a 1 there. I think of it as moving in accordance with the slope. What's the slope of this line? Yeah, the slope, which is the change in y divided by the change in x, is 16 over 1. Sometimes we say the rise over the run. Rise over the run. So for myself, when I do these things, I look at this and I say, you know what? If I go over 1, let's start out here. Go over 1, I have to go up 16. So I get another point like that. Let's do one more point like that. Again, I can go over 1, and then how far up do I have to go? 16. Yeah. So 16 like that. And I can get as many points doing that as I'd like. So it's an easy way to graph things if you have it in this form. And the other thing that's nice about this form is that a lot of times the y-intercept is an important point. In this case, it's telling you the delivery charge, all right? And then the slope is telling you how much per pie. So in my mind, the easiest form would be to graph it in slope-intercept form. Is it needed to graph your equation? Will help you better understand things. It's not a bad idea to to graph your equations. It shows you how fast this is growing, shows you what the y-intercept is. Sometimes, depending on your graph, and I don't have the data here off the top of my head, I think I can come close. There was a study done in 2020 about the number of wolves in the Upper Peninsula. So I'm going to call that, I don't know, year whatever. I guess if I was going to call that year 0, I should actually have it on the y-axis. But there were 691 wolves. In 2022, there was 631 wolves. So if you actually took the time to find the equation of the line here, then there's a nice interpretation for this point here. Keep in mind this is the year, and this is the number of wolves. So what would be the interpretation of that point then? For whatever years this is, how many wolves would I have in this year? 0. So that'd be the years, if this linear trend were to continue, that would be the year the number of wolves in the Upper Peninsula vanished. They went extinct in the Upper Peninsula. Now, that population bounces around a lot. Let's hope that that's not what the case is, but that is a nice interpretation. Let's do one more thing with this one, and this is something that I outlined for myself to cover with you. And let's again find the slope of a line between these 2 points, but then interpret it in a couple different ways. So let's think here. The slope is going to be the difference in the y coordinates. So I'll call this my x1, y1, x2, y2. I hope somebody's awake now. All right. 631 minus 691 over 2022 minus 2021, or 2020. So it gives me negative 60 over 2. What are the units here? What's that negative 60 represent in the numerator? Wolves. Yeah, it's the number of wolves. And I don't have enough room to write that. How about the denominator here? Years. What if I divided this so that I had a 1 in the denominator? What would that be now? Negative 30. Let's keep the same units. Wolves per year. And so that's a nice interpretation of the slope now when I got this into kind of a unit there. It's the number of wolves per year that you're losing up there. So if that trend were to continue, it'd be about 21 or 22 years before they would all disappear. Now, like I said, hopefully, and I don't think it's likely that they're going to have a straight linear trend all the way down. So, good questions there. All right. Let me keep going. How can you tell from the value of R whether the data is strong or weak? Well, if it's a strong or weak, well, yeah, it is strong or weak. What's the value of R have to be if it's a strong correlation? It's close to what? 1 or negative 1. So close to 1 or negative 1. What if it's weak? What's a weak correlation going to look like? Yeah, close to 0. Close to 0. That's what a weak correlation is going to look like. Close to 0. All right.
We have to go. She has an appointment. She's my ride.
Kind of funny that you're leaving now.
Oh,
Go ahead. Go ahead. Yeah, it's
I'm
okay.
sorry. I didn't know.
If I had feelings, they'd be hurt, but you're okay.
No, don't. Don't take it personally. Have a good one.
You too. Oh, and for extra credit, never mind. No, go ahead. See ya. Ciao. All right. All right. Yeah, so the question was, is substitution when you set those equations equal to each other? Sure. That's what substitution is all about. You can do this in a lot of different ways. So I'm assuming that you start out with a system of equations like this. Y equals 9x plus 11 and y equals 36x plus 47. Assuming that, then yeah, you can take this expression here, which is y, and substitute it in there, and then solve for both of them. Now, chances are on an exam, you get something easier like this. You don't always have to get something nice and easy like that in order to use substitution. You can get other crazier equations like, say, 2x plus 3y equals 6 and y minus 2x equals 7. Now in this case, it'd be easier to solve here for y than it would be to solve here for y. You don't get bonus points for doing this the hard way. It's easier to get y by itself here. What do I have to do to get y by itself here? Add 2x to both sides. So it's going to be y equals 2x plus 7. And then I can take this expression and plug it directly into here. I don't need to solve for y in both of them. I've got my y there. So it'd be 2x plus 3 times my 2x plus 7 equals 6. And then you go ahead and finish solving from there. So if I distribute 2x plus 6x plus 21 equals 6, what would you do next? Any suggestions? Yeah, 8x plus 21 equals 6. 8x equals 6 minus 21. Moving it to the other side changes signs. So that's negative 15. Thank you, Nidai. Divide by 8. And bam. There you go. Now, I guess there is one more thing that I have to do for a problem like this. And that is I have to figure out, well, what's the y value? Because remember, a solution to your system of equations is really where the two lines cross each other. And two lines cross each other at an x and a y coordinate. So I need to figure out the y coordinate now. So you got a couple places you can do that. I would take this equation here. What do you think the advantage is of plugging your value of x into that one? You've already got y solved for, right? You just have to plug in the value of x. So let's see, that's going to be y equals 2 times negative 15 over 8 plus 7. And let me plug that in here. Negative 15 over 8. Now they invented calculators because the brain is a terrible thing to use. So let's see if we can't get our calculator to do a little bit of work for us. Oh, and this thing takes forever to start up. I apologize. While that's working, let me pull up Desmos. What do you expect to see when you look at the graph from Desmos? Are these graphs going to cross each other, or are they going to be parallel? They should cross. In fact, we should be able to figure out exactly where they cross. So we've got 2x plus 3y equals 6. One really cool thing about Desmos is you don't have to have y solved for. And then y minus 2x equals 7. So let's take a look and see how close we come to that point there. So I want 2 times, and I'll do a fraction for myself. Well, actually, I'll do it the way you probably would put it in. So you don't really need the times there. It understands that if I have a parentheses that are multiplied. Negative 15 divided by 8, parenthesis, plus 7. 3.25. Okay. If you wanted to, and a lot of times I do, I like fractions, 13/4, but 3.25, that's pretty good. Let's take a look at what negative 15 divided by 8 should be. This should be negative 1.875, I'm guessing. Ooh, yeah, on fire today. All right, let's take a look here. The cool thing about Desmos is that you can click that point and it says, yeah, that's where you're at. And notice that it matches exactly what we expected, right? So that's pretty nice. All right, that was a good question. Thank you, Lily. All right, let's keep rolling. There's a lot of questions here. You guys did a really good job working through these things. Let's see. Another one here was to find the line of best fit using data. Now, I'm not going to make you do this with a graphing calculator or a spreadsheet. There's a lot of really cool ways to do it. I don't think it's that hard on a spreadsheet. I think I might have even made a video for our YouTube channel on that. But this is not something I'd worry about from a spreadsheet. You can do it. Going back to my favorite platform, Desmos, let me just write a few random points. Let's do 3, 5, 4, 7, 9, nope, 9, 11, 13, we'll do 14, 17, and 20. So not a perfect linear relationship, but not bad. Let's get rid of these two, and then let's fit this to our data. So the cool thing is that Desmos can easily figure out these kinds of relationships. You just click this little button here, add a regression, and then there you go. So about 2.46 times x minus 0.46. So pretty good. By the way, do you think the value of r here would be closer to 1, closer to -1, or closer to 0? Closer to 1. Yeah, nice. And if you take a look here, Desmos actually gives you that value of r, 0.99, so it's really close. All right, just a couple more here, so let's keep it rolling. Let's see. How do you find the slope and intercept form using the negative points of -2 and -5, -4, and 3? So this is kind of a nice review of one that we did earlier. So one way or another, you're going to have to start this by finding the slope of a line. At some point or another, you're going to just need the slope of a line. So we'll start with that. And then it'll be our choice of slope-intercept form or point-slope form, and I'll leave that to DeJeanette. All right, so here's our 2 points, -2 and -5, and -4 and 3. For no particular reason other than just my whim, I'm going to call this x1, y1, and this is x2, y2. To find the slope, I need to find the difference in the x's and then the difference in the y's. Make sure it's always the difference in the y's on top, difference in the x's on bottom. And we got to be a little bit careful here because of all these negatives. It's 3 minus -2. And then -5. Thank you. Thank you. -5. Appreciate that. -5 over -4. Now I can do my -2. What happens with the double negative here? Becomes an addition, so that it becomes 8. Let's slow this down a little bit. The double negative becomes a positive. What's -4 plus 2? -2. Overall, what quotient do I get here? -4. So that's my slope. Now, how do you want to proceed here? You've got a slope and you've got a point. So you can either use the slope-intercept form or the point-slope form. What's easiest for you? Point-slope form? Okay. So the point-slope form is going to be my y minus y1 equals m times x minus x1. The slope-intercept form looked good on the previous example because one of our points was 0. But if it's not 0, yeah, maybe it's more work than not. I like this one. It's, pretty straightforward. Now, it doesn't matter which point you choose here. Since I've already labeled one of them x1, y1, I'm just going to choose that one. Although, in honesty, at least this one has one positive and one negative instead of two negatives. So maybe you want to use this one. Let me do it with this one just to practice our double negatives. So it's going to be y minus -5 equals -4 times x minus -2. I'm trying to model here something for you, and that is when I substitute in these negatives, I did so with parentheses so that you can take a little extra care in simplifying this. This becomes y plus 5 equals -4 times x plus 2. Notice that before I tried to distribute that -4, I cleaned up what was inside the parentheses. Y plus 5 equals -4x minus 8. What's the last step here? Subtract 5. Y equals -4x minus 13. Nice. Now, how do I know I got this right? Or how could I prove to myself if it was like really critical that I passed this test, I got this right? I'm looking at that going, oh, I don't know, that number 13 scares me. It's a big number. It's an unlucky number, right? So what if I was worried about this? How could I figure that I got it right? I got a couple answers, but I'm not hearing anything distinct yet. Well, my line is supposed to pass through both of these numbers, right? Let's see if it works. If I put in a -2 here, so check at -2, -5, well, that's my x and that's my y. So does -5 equal -4 times -2 minus 13? What's -4 times -2? 8. Positive 8 minus 13 gives you, it checks. And you can do that with both of them. It should work through both of them. If it only works through one, there's a mistake. But if it works through both of them, then we know you got it right. I'd test the other one, but I know you have complete faith in your math instructor, so we'll just bypass that. All right. Let's keep going. Let's see. If where the lines cross is not clearly visible on the graph or table, how can I find the exact coordinate? You can't unless you actually have the equations. So unless you have the equations, the best you're going to be able to do is estimate it. If you have the equations, like maybe we did up here, then you can solve for that point. But if you're just looking at the graph and it's not like Desmos where you click the graph and you get those points, yeah, without these equations, the best I could do is say, well, it's a little bit bigger than -2 and a little bit more than 3. So you couldn't. You need the equations to actually find that point if you didn't have them crossing at a nice friendly spot. All right? Appreciate that. Whew. I think that's it for one round of everyone's questions. Now, one thing I notice is that I need you guys a little bit more engaged, so we're going to stop things here. I want you guys to spend some time working on some problems because, what's that?
I need to work on word problems.
Work on whatever you guys want, but let's do a little thought experiment. So the Yankees and the Blue Jays are in the World Series right now, right? You think their manager says, okay, let's get ready for the game. I want you to watch some videos. It's not exactly about baseball. No. He's going to have you get out in the field and practice, actually do it, right? Same thing with getting better at math and understanding these things. You've got to do it for yourself. I know, you just wanted to just listen, you know. And then somehow, magically, my voice transfers from your ears to the paper and doesn't stop in between, and that doesn't help out too much. So we've got to actually do something. So I'm going to finish checking in your exam or your questions here, and then I'll pass them back. But I want you to work together. I'll let you choose your own groups today. So work together on some of these questions. I'll work around, I'll cycle around. If you have specific questions that you're just, I just can't get this one, let me know. By the way, I will post a few of my own thoughts. I'll post this, and you can thank my wife on this one, because I left home this morning, went to play hockey, and I left this at home. So she took some photos for me and sent it to me. But this is what I was thinking when I went through some of the things that I thought were kind of the major topics for this course so far. Let's see. You should be able to write an equation and solve for how long it takes to get up to a particular value. That was one we practiced in section 3.4. Conversions. I really like, our conversion problems. It's certainly something that's very handy, is for you to be able to convert here. And we did it with conversion factors. You could also do it with ratios and proportions. So that's a nice thing to be able to do. Let's see. Page two. We practiced some of this here today. Find the slope of the line between 2 points. Actually, maybe find the equation of the line once you found the slope of that. So here's the exact numbers that I was trying to go for earlier. Solving system equations. I will get these posted as soon as I can, like as soon as I grade your stuff here. I don't have anything for section 3.8 and 3.9 because you just had a quiz on that stuff. So that part I didn't do, but I will post some of these if you want to look at something. Pair up or groups of 3. So try and keep them to groups of 3 or less, and start working on some of these. I'll post these things first. That way, if you have any questions, then you can ask them right now. So, okay.